All right, so today's lesson is 12.2, pairs of angles. All right, so we already looked at a lot of aspects. Now let's add to that pairs of angles. And the first one is something that comes up all the time in geometry. And anytime you're dealing with angles, it's a popular concept, and it's the idea of complementary angles. It's really spelled complementary, but most say complementary. C-O-M-P-L-E-M-T-A-R-Y. Complementary angles. But again, spelt more like complementary, though I have not heard people pronounce it that way. But then you got the old potato thing anyhow. All right, what are complementary angles? They are simply two angles where the sum, so we're adding, right? Sum means adding, where the sum or the adding of their measures is 90 degrees. Complementary angles. Two angles where the sum of their measures, where when you add up their measures, you get 90 degrees. Now, to the right, I have the common example of complementary angles. You guys see the little right angle box in the bottom of angle ABD, right? That tells you have a right angle. Therefore, this angle right here, angle ABC, and this angle right here, angle CBD, have to be complementary angles. They have to add up to 90 because the 90-degree angle is made up of those two angles. Has to be. So that's the common example of complementary angles. Here's another way. Again, you don't need to write this in your notes, just watch. Okay, so if I have a 90-degree angle like that, if I stick a ray at that vertex, then the two angles inside have to be complementary. They have to add up to 90 if the whole big angle is made up of those two, and the big one equals 90. You follow? Do you understand? So that's a very, very common example. Now, this can be spun around all kinds of different ways. Let me see if I can do this without. So it doesn't matter how this thing is oriented. I'm going to come down here. It's still, look, those are still complementary angles. If it's sitting that way, they're complementary angles. If it's sitting like that, they're complementary angles. If it's sitting like that, they're complement. Does it matter which way it's rotated? No, as long as you know you have a 90-degree angle and two angles that make up that 90, you got to have complementary angles, right? The spinning of it makes no bearing on it, even if it's little or, little or big, they are complementary angles. Two angles where the sum of their measures is 180 degrees. Now that's the classic example right there. But it doesn't have to be that way. Look at B. Are angle P and angle Z complementary angles? Well, if I tell you they are, then what's got to be the measure of angle P? So if I told you, hey, angle P and angle Z are complementary angles, somebody tell me what is the measure of angle P? Kristen? Not with my math. Luke? Not with my math. Juliana? How many? 58 is the answer, right? So 58 and 32 is 90 degrees. What did you say? 50? Yeah. It's got to be exactly 58, right? If the other one's 32, yeah, 90 minus 32 is 58, right? It's got to be if they're complementary angles. Now, see, one angle's in one place, the other angle's in the other place. That's fine. As long as the two add up to 90 degrees, we're going to call them complementary. And if you know two angles are complementary and you know the amount of one of them, you can figure out the amount of the other one. So that's this example. If the measure of angle JKL, now they don't show us the angle. We don't know where it is. They don't show us a picture of us. But they tell us that its measure is 70 degrees. Find its complement. So what they want you to tell them is, what's the measure of its complement? It's pretty easy, right? Its complement is going to be 90 degrees minus the 70 degrees, right? Because if the two add up to 90, if one of them's 70, the other one's got to be 20. And that's all you're doing on those. If your book says make an equation on problems like that, don't worry about that because that's so simplistic. We don't need to worry about that kind of stuff. It then makes something pretty simplistic a little bit more of a pain when it's just so easy to do. Right? So if two angles are complements, if one angle's 10, the other one is
980.
Think in your brain. One is 10, the other is 80. One is 40, the other is 50. One is 5, the other one is, right? It's got to be that way. One is 100, the other is, there is none, right? You can't have complementary angles if one of them is 100. All right, what did I say, 100? Yeah, right? Can't. All right, in order for you to have complementary angles, both angles must be what type of angles? No. The two angles each have to be what type? Acute, right? It's the only way you're going to get to add up to 90. That is the only way. So one more question in this frame of mind. Find the complement of a 32-degree angle and say the answer if you know it. 58, right? Again, just 90 minus 32, right? But notice the terminology. If we ask for the complement, we want to know how many degrees the other angle is. Okay? If they ask for the actual physical angle, then you got to use the proper notation. All right, so that's complementary. There's also a situation where you have two angles where the sum, the adding of their measures is 180 degrees. What's the term for those? Amber? No. It's a straight angle, but the two together are called this. Raph? Supplementary. Again, spelled supplementary. Supplementary. Supplementary angles. So if they add up to 90, they're complementary. If they add up to 180, they're supplementary. How can you keep those two straight, not get them confused? How can you keep from getting confused? Complementaries add up to 90, supplementary add up to 180. Who's got an idea how to keep them straight? Juliana? Okay, but how is that going to help you to remember? I'm trying to find a memory aid to keep from saying, because some people think complementary are two that add up to 180 and supplementary are two that add up to 90. How do you keep it straight, which is which? Daniel? Okay, in supplementary there's two P's and therefore what? Yeah, but there's two angles in complementary too. So that both have two angles. So I don't see how that's going to help me remember. Kristen.
Straight and supplementary, those are tests.
Straight and okay. So what if you don't have the common example and the supplementary angles look like that? Do you see any straight angle anywhere? This and this? Those are supplementary angles. So that won't work either. All right, come on. Memory aid. Edward.
Sup means like sup is close to the word sum.
And sum is close to people, and people are close to angles, and angles are close to straight, and straight is close to supplementary. Right. Got it. Great memory aid. All right, here's usually what I do. I just go alphabetical. Complementary is the smaller one. C comes before S. 90 comes before 180. Right? So 90 comes before 180. C comes before S. That's the way I remember them. But you have to remember them. Don't get them mixed up. It's really, really important you keep straight supplementary and complementary. All right, here is the common example, or the most popular example, of supplementary angles. Anytime you have a straight angle and then two angles that make up that straight angle, they have to be supplementary. They have to be. There's no other possibility. So that's the common example. And again, just like before, this common example can be spun any which way. So when we take these supplementary angles, it could be like that, right? They're still supplementary angles. Could be like that, they're still supplementary. Could be like that, they're still supplementary. Because you have that straight angle. And again, we're talking about one of the angles being here and the other one being there, right? Those two angles make up that straight angle. Therefore, they've got to be supplementary. They have to be. Christina. All I'm trying to get you to understand is the picture can be, so here's an angle here and here's an angle here, but because they're part of a straight angle, they have to be supplementary. I could spin it this way. It's still, well, my numbers did goofy stuff. So apart from my numbers being goofy, you still have one angle here and one angle here that make up a straight angle. They have to be supplementary. I'm just trying to tell you that this line doesn't have to be straight. The line can be spun because you're talking about the two angles that make it up. All right. So that may not have answered your question, but that's kind of a object-spatial relationship issue. So you can come by later and I can try a few other ways to help you to get it. But that's the idea. You're made up of a straight line. The orientation can be any different way. It's still supplementary angles. So if I told you for B, angle K and angle L are supplementary angles, you already know angle K is 50. What has to be the measure of angle L? It's got to be 130, right? It has to be. If I told you they're supplementary, then this has to be 130 degrees because the two of them add up to 180. Now again, they're not right next to each other. We have a name for that. I'm going to explain that in a little bit. But they're still supplementary angles. Now it's common for them to be right next to each other. This view. That's the common way. But it can be this way. As long as the two measures add up to 180, they're supplementary. So go ahead and answer C. Find the supplement of a 17-degree angle. Guys got calculators in front of you? Or you can do it in your head if you want the mental exercise. Keep you from having Alzheimer's. But I don't think you have to worry about that for a while. Or just become a teacher, then you should be in good shape. Okay, so hopefully you're thinking 180 minus 17, right? And so you end up with what? Is that 163 degrees? Would be the supplement. Does that make sense? Okay. So you'll have various questions like that. So let's do a little bit of mental math. What's the supplement of an 80-degree angle?
100.
Would be 100 degrees. What's the supplement of a 140-degree angle? 40 degrees. What's the supplement of a 1-degree angle? 179, right? Etc. That's all you're doing there, two angles that add up to 180. Okay, so here's one more example of how they might ask you this question. They might give you a drawing, and they're showing you that angle GEF is 148 degrees. Therefore, what is the measure of angle DEF? So what would be the measure of angle DEF? Go ahead and figure it out. So somebody raise your hand and tell me the answer. What's the measure? Emily?
32.
How many?
32.
32 degrees. How do you know that it's 32 degrees?
Right, 180.
How do you know they're supplementary angles? I didn't say they were supplementary angles. Right? Did I say they were supplementary angles, this one? I didn't say that. So if they were supplementary, she would be correct. It's 32 degrees. Are they supplementary, Edward?
Yeah.
How do you know?
Because when you add them both together, they make 180.
No, we don't know if you add them both together, you get one. We don't know that. We assume that to get to 32. How do we know they're supplementary, Allison? Because the two of them make up that straight angle. And Christina, that's what I was trying to show you earlier when I was spinning that. What I was trying to tell you is this thing, whenever the two angles make up that straight angle, that's supplementary. So when I look at this, I say, oh, here's that straight angle, and the two of them make up that straight angle, therefore they got to be supplementary. That's the thinking, okay? So yes, it is 32 degrees, Emily. But not because I said they were supplementary, because you would know from the picture they're supplementary. Just like you would know from this picture that the two are complementary, okay? And you'll see homework problems like that. All right, next, another term. And again, as I told you, a lot of terms this chapter. You got to keep up with all the terminology because there's a ton of it. All right, there is a ton of it. All right. Two straight angles form two pairs of supplementary angles. Whoa. Yeah, two pairs. Do I want to say that? Yeah. Okay. I can get so confusing here that I'll mess you guys up, and I don't want to. All right, let's list the pairs of supplementary angles. All right, let's do it that way. Would you agree that angle 1 and angle 2 are supplementary angles? Do you agree? Therefore, do you agree that angle 4 and angle 3 are supplementary angles? So we did top and bottom. Agreed? So the two on the top, right? And then the two on the bottom. Agreed? Well, not only that, though, do you agree that angle 4 and angle 1 are supplementary angles? How about these? Because again, you see that straight angle? And therefore, then, how about angle 3 and angle 2? So that's what I meant by two pairs, but I know the language. I wouldn't ask this question here, but I just want you to know, look at all the supplementary angles. Maybe it would be better if I said 4 here. I don't know. If that's clearer in your brain, it might be clearer if you put the 4 up there. Okay? So there are 4 sets of supplementary angles. 4 sets of supplementary angles. And that leads us to another term. So another term is adjacent angles. Adjacent. A-D-J-A-C-E-N-T. Adjacent. Have you ever heard someone talk about somebody was parked in the adjacent parking spot? Have you ever heard that term? If you watch the news and stuff, they'll mention occasionally something adjacent is the concept is kind of like right next to it. But for angles are adjacent when the angles have a common vertex In other words, both angles have the same vertex, and they also have a common side. You need both aspects to be adjacent angles. Let me put this higher so you guys can see a little better. So I want you guys to look at the picture there, and there is a pair of adjacent angles. But to be clear, we have to name those angles. So one of the adjacent angles is angle ABC. What is the angle that's adjacent to angle ABC? Can somebody give me the letters, Nia? CBD is correct. Angle CBD. So let me try to use the color to help you guys to see that. All right, so here's angle ABC, right? And here's the vertex right here. Doesn't angle CBD share the same vertex? Right? Do they share the same vertex? Do they share a common ray or a common side? Yes. So that common side shared is always going to be in the middle for adjacent angles. Always. 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 So you got to be careful. So I want to show you something that's not adjacent angles. At least not this pair. Don't draw this. I just want you to see something. If I had that big blue angle, right? And then I had inside this yellow angle. Is the blue angle and the yellow angle adjacent angles? And technically, no. Because the shared side really has to be in the interior. So technically, no. Even though they share the same vertex and share one side, they are technically not adjacent because the blue one is made up of part of the yellow one. I know it's kind of tricky, but that's the idea. Now, I could say this. The green angle and the yellow angle are adjacent angles. Okay, they're right next to each other. When someone says the adjacent parking spot, they mean the parking spot right next to them. So adjacent angles are right next to each other. They share a vertex and share that common interior side is probably the better way to say it, but the technical definition just says common side. Now, if we go back to these supplementary angles, you got all kinds of adjacent angles. Are angle 1 and angle 2 adjacent angles? Yeah, they share that vertex and that common ray. Are angle 2 and angle 3 adjacent angles? Yeah, they have that common vertex and they share that common ray. Are angle 3 and angle 4 adjacent angles? Yeah, they share that common vertex and that common ray. Are angle 4 and angle 1 adjacent angles? Yeah, they share that common vertex and that common ray. Are angle 4 and angle 2 adjacent angles? No. Are angle 1 and angle 3 adjacent angles? No. Okay. Let's go back. Anything else back up here? You can see these two are adjacent, right? Et cetera, et cetera. So adjacent, right next to each other. All right. What else? Some more terms. Two straight angles, I'm going to use my red here. Two straight angles form two pairs of vertical angles. Two pairs of vertical angles. V-E-R-T-I-C-A-L, vertical angles. And here's the key. Each pair of vertical angles have the same measure. So there's two pairs. Can you see the orange angle, angle 1? Right? Here's what we're saying. The measure of angle 1 must equal the measure of what angle? What's the vertical angle to angle 1? Say it if you know it. Angle 2. Angle 1 and angle 2 are vertical angles. As well, the measure of angle 3 must equal the measure of angle 4 because they're also vertical angles. See how we get two pairs of vertical angles? Anytime two straight lines intersect, you get 4 pairs of vertical angles. So guess what? If the measure of angle 1 is 40, what's the measure of angle 2? If the measure of angle 1 is 40, what's the measure of angle 2? 40. They're vertical angles. They got to be the same. Measure of angle 1 is 32. Measure of angle 2 is 32. If the measure of angle 3 is 140, measure of angle 4 is? All right, now let me do something completely unrelated. What if, forget all what I just said, what if the measure of angle 1 is 40? What's the measure of angle 3? If 1's 40, what's 3? Kristen? Whoa, how'd she do that? She went back to what? Say it if you know it. Supplementary angles. She got to be looking. They're all over the place, right? So, if I told you 1 was 40, like Kristen, you could tell me 3 is 140. Therefore, you could tell me 4 is 140. And, of course, 2 is 40. If we know 1, we get all 4. See that? If you know 1, you get all 4 if you have vertical angles. So let's look at 3 here. Man, why did I write that so big? If the measure of angle 8 is 32 degrees, by the way, it's not for tonight, so don't worry about it tonight. It'll be tomorrow. If the measure of angle 8 equals 32 degrees, find all the other angles. I'm going to label my drawing. It'll help me to think. I'm putting a 32 there. Mark around the drawing the rest of the angles. Tell me the measure of angle 5, the measure of angle 6, and the measure of angle 7. And once you got the idea, it's quick, right, Aaron? And if you can do mental math in your head, it's even quicker. Unless you're mental, then don't do it in your head. All right. Brendan, what do you got for 6? Does everybody concur? Because they're vertical angles, right? Right? Daniel, what do you got for 5? 148. I hope you agree because it's a supplement of the 32, whichever way you look at it. And therefore, 7's got to be 148. And there you go, right? You get them all? Got it? Hey, a lot of terminology. You got to review, guys. Got to review.